So in the previous video, we discussed how to solve system of equations by graphing. So now we want to talk about a different method, which is algebraic in nature, and it's called substitution. All right, and the way that we're going to do this, I'm just going to lay out the steps first, and then we're going to follow the steps. And as we lay out the steps, I'm actually going to follow it with this example, so you can kind of see what each one means. And then we'll do couple more examples, and then leave some examples for you to do. But we're going to try to solve this by substitution by, first of all, taking one of the equations and isolating one of the variables. And it doesn't matter whether it's x or y. So in this particular instance, what I'm going to do in this example down here is I'm going to identify this as equation 1. I'm just going to call it equation 1. And this is equation 2. And the only reason I'm going to do that is so that I can identify for you that I'm going to choose to take equation 2 and solve it for x. All right, and the reason I am making that decision is because x right here is by itself. In other words, there's no number in front of it. So that's pretty easy to isolate that because all I have to do is subtract 2y from both sides, all right? And so then I end up with x is equal to 4 minus 2y. So that's the first step. Then the second step says, substitute that expression into the other equation and solve. So what does that mean? Well, it means that I say, therefore, in equation 1, I'm going to go 5y minus 7, and instead of x, which is here right now, I'm going to put 4 minus 2y. And then that is equal to 29. So I get 5y minus 28 minus 14y, actually, sorry, plus 14y, because it's minus 7 times minus 2, is equal to 29. Okay, and then the third step says substitute the answer. Sorry, we're still in question 2 or step 2 because we're still solving. So I guess it's not just substituting; it's also solving in this step. So we'll just keep going. So what we do is 14y plus 5y is 19y is equal to 29 plus 28. We're just going to bring this 28 over to the other side of the equation. So I get 19y is equal to 57. And that means if I divide by 19, that y is equal to 3. Okay. Then the next part says substitute the answer into one of the equations to solve for the remaining variable. What I do is I substitute it into here. Okay, so x is 4 minus 2y. So I say x is 4 minus 2 times and y is 3. Okay, we go 4 minus 6, and that's minus 2. So my solution is x is minus 2 and y is 3. And just like with graphing, you can go back and verify your solution. You can check to see if it works. So let's do that. So we're saying 5 times y, and again, y is 3, minus 7 times x, and x is minus 2, is supposed to equal 29. So let's see if it does. We get 15 plus 14 equals 29, and 15 plus 14 is 29. So we can say, yep, that worked. And in the same way, we can go 2 times y is 3, plus x, which is minus 2, is supposed to equal 4. So that gives me 6 minus 2 is equal to 4. 2 times 3 is 6, and then that minus just gets rid of that plus sign, so it's just minus 2, and that means 4 is 4. And I say, yes, that also works. So now I'm confident that my answer is correct, just like when I was graphing. All right, so let's do another example. Here's another system. So I'm going to call this equation 1 and this equation 2. And what's going to happen here is you'll notice that x and y are both by themselves in the sense that there's no number in front of them. So you can do this either way. You can solve it for x or for y. And you could even down here solve for y. So you've got a number of different options. I'm going to take x plus y equals 5. And all I'm going to do is I'm going to replace y. So I'm going to say y then is 5 minus x. All right, just bringing that x over to the other side and changing the sign. So then I take that and I substitute it into equation 2. So I say, therefore, in the second equation, I'm going to write 2x minus, and then y is going to change to 5 minus x. I make that substitution. And that's why this method is called solving by substitution, okay? Because we're solving for one of the variables in one equation and substituting into the second equation. So that gives me 2x minus 5 and then plus x. You just have to be careful of your signs, okay? So that means 3x minus 5 is equal to 4, okay, because x and 2x are like terms. And then we bring the 5 back this way, so we say 3x then is 4 plus 5, which means that 3x is 9, and that means that x is 3. Okay, and once I know that x is 3, then I say, therefore, y is 5 minus x from up here, all right? So I just replace x with 3, and I say sorry, I don't need to write that out again. 5 minus 3 is 2. So if x is 3, then y is 2. So my solution is 3 and 2, and then I have to check. I just verify my solution. So to check, the first equation is x plus y equals 5. So we're going to go x is 3 plus y, which is 2, is equal to 5. And we say, yes, 5 is equal to 5. So this one checks out, right? That one's good. And then we do the second one. 2 times 3 minus 2 is supposed to equal 4. We get 6 minus 2 is equal to 4. And that means that 4 is equal to 4. And we say, yes, that also checks out. So then I know my answer is correct. And you can state your answer like this, x is 3, y is 2, or you can state it as a point, just like we did when we were graphing. Okay, so the solution is 3 and 2. Okay, here's another example. So let's do this one. And again, when you look at these equations, deciding what you're going to start with in terms of a substitution is based on if a variable is by itself, meaning there's no number in front of it, that's the best choice. So that's what I'm going to do. So I'm going to say in equation 2, and you don't have to number them necessarily, it just helps sort of order what we're doing. We're going to go 4x plus y equals 5, and then we're going to bring this 4x over there. So we're going to say y is 5 minus 4x. And then we're going to say, therefore, in equation 1, then, we're going to make our substitution. So we're going to say 2x minus 4 times, and then instead of y, we're going to put 5 minus 4x, and that equals 7. Then we're going to solve. So minus 4 times minus 4 times 5 is minus 20, and minus 4 times minus 4 is positive 16x equals 7. Okay. So then we get 16x plus 2x, that's 18x minus 20 is equal to 7. So that means 18x is 7 plus 20. We bring this 20 to the other side. And that means that 18x is 27, which means that x is 27 divided by 18. And if we reduce that, we get 3 over 2. We divide them both by 9. Or you could write it as 1.5. Okay? And then we say, if x is 3 over 2, what is y? So y is 5 minus 4 times x, which is 3 over 2. That gives me 5, and then minus 6, because 4 divided by 2 is 2, and then 2 times 3 is 6. Okay? Or you can just take your calculator and multiply 4 by 1.5 if you don't like working with fractions. You should. Fractions are your friends, but you may not. So we end up with a solution of 3 over 2 and minus 1. That's our solution. And then what we do, again, is we go and check. So if we're going to check, we're going to plug into the first equation here. So 2 times x is 2 times 3 over 2, minus 4 times, and then y is minus 1. And that's supposed to equal 7. So these 2's cancel, I get 3. Minus 4 times minus 1 is positive 4, equals 7. So 7 equals 7. So we say, yep, that worked. And then we check this one. So we go 4 times 3 over 2 plus y, which is minus 1, is supposed to equal 5. So we get 4 and 2 reduced to 2. 2 times 3 is 6 minus 1 is equal to 5. And then we say, is 6 minus 1 5? Yes, it is. So we say, yes, that's correct, which means this verifies, and I know that I'm right. Okay, so that's the method of substitution. So there's some practice here for you. There's a couple of questions to try. But that's the idea. That's the idea of substitution. So we'll leave it at that.